And yeah, without further ado, let's welcome Leong to the stage.
Thanks, everyone. Hello, Sydney. Hello, everyone. Good to see everyone here. I'm Lai Fong, or Leong, call me Leong, from Kuala Lumpur, Malaysia. It's my first time coming to Sydney, and it's really a lovely city, a bit cold, I would say, raining, but all good, all good. Also, the train disruption, very welcoming intro. But anyway, thanks for joining today's sessions, despite the train disruption and all. So today I will be sharing a talk on agentic AI with Gemini. While we are starting this talk, just a quick check. Anyone has watched the I/O keynote events? Is already live happenings today. For those who are interested to know what is the latest technology news updates from Google Technologies and all, go to this Google I/O events. There are a lot of new updates coming in also. And the very favorite thing is on this year is on AI, and also more towards the AI agent part. So today we'll be sharing and learn a bit more on agentic AI. So just to have a quick show of hand, anyone here is technical person that have a lot of experience working with AI, or maybe already doing some agentic AI? Cool, cool. But all good. You still learn. I hope that I can share a lot of some insightful information about the agentic AI, and then we'll go through an example how you can build it. Surprisingly, very, very simple and easily. You can do it after the talk, I promise you. So let's take a look on today's content. We'll go through the quick introduction on a bit on the AI evolutions from AI to generative AI, and also the AI agent components, a bit of theory and all, but it's very, very important. Once you manage to understand this, and then when we go through the coding part, you kind of be able to easily relate, and you can easily resonate and understand also how you can build an AI agent later on. So then I'll also share a little bit of example on the AI agent example with the Gemini model. Then we'll just quickly wrap up with key takeaways. So, generative AI models to AI agent. I think we had a lot of this generative AI, but what exactly is generative AI? Maybe someone want to give it a shot? What is generative AI? LM, yeah, can directly relate to generative AI. Anyone else? No call? Maybe I should give some swags, some cookies from Kuala Lumpur if you manage to get one. Just to give a little bit of motivation for you. But let's take a bit of evolution of AI. Traditionally, we do a lot of all these rules set based programming. We have all these if, else, and all. We define, like if you want to classify a cat, what the cat has in features, right? So we can say it has 4 legs and then 2 ears and fur and all those things. We kind of list out all the characteristics of the cat, then we kind of match it. It's like rule-based programming, right? But then the problem is, this is too complex, and in a lot of animals also have a similar type, right? Then how do you really differentiate between a cat and a dog? Both have fur, have the same 4 legs and all, right? So that's a limitation on the programming, and it becomes to this wave of machine learning or back then in around 2012, a wave of neural networks where the machine learning can use the trained model, be able to differentiate. Once you train the model, you can use the same model to differentiate, is this a picture of cat or a dog, without explicitly mentioning what are the rule set. So this is the evolution from traditional programming towards the neural network era. Then as the technology evolving, so it's kind of cool at some time, but then things also getting more complex, and we do not certify on what is delivering right. What else you can do? Remember the old days, not too old, 2 years back when the ChatGPT it gets so popular, everyone gets so fascinated on it, right? So that's where the generative AI get attention on. It's not just something started, but getting attention on. Is how it does is we use the LM model is here. So we are using a large data set and train on a very, very large model. That's why it's called, LM stand for large language model. So it's a very large model with billions of parameters being set. With the model being trained, then instead of just doing the prediction, now the LM model can actually describe the cat, or even another example is it can directly generate a new image of a cat that is totally new and artificial. There's no existing of this cat. So it gained a lot of interest and creativity from a lot of people. Right now, you can see opens up a lot of much more possibility what you can do with AI or generative AI. So what is generative AI? Is actually simply put, the generative AI is generative, is generating a new content using the AI technology. So it's called generative AI. So that's the refresher on what is a generative AI means. So yeah, this is about. So it can generate the new content, and that differentiate between the traditional predictive AI and the new era of generative AI. So if you still remember last time, not so happening nowadays because it has improved a lot, right? You kind of encounter this response before. As an AI like English model, I do not have the latest data being trained, so I cannot answer this question, right? Why is this happening? Because the LM model is being trained by a certain time frame of data, let's say from 2021. So if you ask any question like the latest news, you want to get to know what is happening on the Sydney train system now, right? It cannot answer because it doesn't contain the information of the current data. So then it becomes a very big problem then, because it doesn't make sense for the model to keep on retraining every single day, right? It costs too much. Then the question is, how can we solve this problem? It's a very valid problem, right? And we need to solve this to make it into production or get benefits of the LM model in our application. So, anyone? How can we solve it? We don't have this problem anymore, right? So that's actually becoming this concept of, if you have heard it before, is the RAG concept. So I'll give you a bit of, walkthrough on this. So in the early stage, there were only the models. So you ask the question, and then maybe then you are not, if there's no external knowledge being given, then if it's the latest information required, then you may not be able to answer it, or it can just simply answer anyhow. So that's where the hallucination coming in, right? So it doesn't know, but it just try to predict anything out. So that's the hallucination. So to solve this, this is called the RAG being introduced. It's called the augmented generation. So how it does, right? We still have the same model, but we can connect it with the latest external knowledge. It can be your company database that you don't want to get sent to the LM to train on your data somehow. All right, so you can just connect it externally to your in-house database. So in this way, it's not just on the latest data information that it is able to give you the answer, but also very supporting your in-house company private data also. So this is actually very feasible with the RAG concept. The idea is just to connect with a latest external knowledge base. So this is a RAG. So then it kind of solves the problem that the hallucination or the latest information is missing or unable to answer, right? So in this way. But then, as it get to evolve from the concept of RAG, then we want to make it more mature in that sense. How it does is that instead of just connecting to the database, we want to also make it to be very flexible to maybe to tell me what is the latest currency exchange for Aussie dollar to Malaysia ringgit, right? So then instead of we try to build our own algorithm or solution, we can just call any of the public API, currency exchange API that has already available, right? So then you have also the extending from the RAG is not just to connect to the database, also is on the tools here. I can connect to any external API, including your company, let's say product information. If you are running a e-commerce website, you have every day new products being insert or added into your e-commerce website, right? But you want to your AI chatbot be able to also answer any of the new product added in. So you can just connect to this tool. We'll take a look how it can be done through coding. So then we are extending a lot on these tools, but also after extend to the tools and all, when it's already ready to go live for production, can we also somehow easily supporting this? So that's where this orchestration coming in place, so that it can easily deploy to any of the cloud, and then also easily to manage the whole LLM solution that you have right now. So this is how it get evolved from just a LLM model, then towards this very simple, let's say the AI chatbot, but with the hallucination. And then we try to solve it using the RAG technology. And then from the RAG technology, we further extend with connecting to a lot more tools, APIs, and also including the deployment part. So all in all, it's actually already having a very unified framework in the place. So let's take a look on AI agent. It's actually a deployed application that uses model for reasoning and orchestration with external tools to achieve the goal. So this is a very simple definition of an AI agent. Now, let's take a look on AI agent components. I promise you it's not going to be very, very technical and something that you can actually digest and understand. So let's take a look. So when we try to break it down, right, what is the AI agent, right? It's an application. So application we need to deploy to the cloud or out, right? So or any, we need to have the deployment part. So combining the model, so we need to connect to the model. For our case today, we are using the Gemini model. Then also capability to connect to the different tools. Depends what are the use case that you want to do. I have given you an example of the currency exchange, or maybe you want to connect to the weather forecast. All these are very much possible, depending on your use case, and with the high level of reasoning to achieve the desired goal or state. So these are the 4 components of an AI agent: the model, the tools, the reasoning, and the deployment. Now, let's take a look. So I will leave the deployment part separately, because that one is just going to the production and all, right? So we will take a look more into this explicitly on the tools, specifically on the tools. Then the reasoning loops and model will just have a very quick walkthrough in that sense. So let's take a look on the tools. So what the tool means is that it allows the agents to interact with external data and services, including external API call. So there are 3 types of what you can connect to. Can be any extension of functions or data stores that you can connect to as an external tool. So this is the tool part. Then next, going into the reasoning loop. So for reasoning loop, right, it's actually an interactive and introspective process for the AI agent to take actions based on what your prompt question is. So this involve a lot of different advanced prompt engineering framework. Maybe you have heard of something like React, change of thought, and all these things. It's under reasoning loops. How it define what is the action needed. So this is on reasoning loop. So far, okay? Not sleepy, right? It's not too technical, right? Something can. So when we already look into these different components, let's take a look on how we're going to build the AI agent. It's not that difficult at all using the Vertex AI SDK. So before that, I'll just going through a very quick operation architecture and all. So we have a LM model, and then we have a user to send in the prompt. Like, I want to book a flight from Austin to Zurich. So you send to the LM. So the model, it will actually try to check, you actually want to book a flight. So maybe you connect to the external tools of the flight. Maybe the Google Flights API, right? Then you can scan through a lot of different flights available. Then after that, you can see like maybe what are the options or dates and all. Then you keep on in these reasoning loops to get all the answers, and then you will send back as a response to the user. So this is how general the AI agent operation works. So it's the same thing here, just that more extension is specifically mentioned this function, data store and extension. Then you can connect to different ways to get the different informations needed, and then you just send it to the back to the application or the end user. So it's just as simple as that. So you have the UI, you have the agent, and then you're just connecting to the model, and then it will actually, depending on your question prompt, it will try to understand the question and then connect to any of the external tools that is related to the question. Then once it's done, you just send back to the as a response from the LM to the application or the user. So let's take a look on. So there is the general overview of AI agent architecture, right? Let's try to relate to the Vertex AI agent architecture. So what we have in place is this agent engine. This is on the deployment part. So you can actually deploy through the agent engine. And then we have the tools. Tools, this is remember we can connect to the external data or services. So you can have the built-in tools like maybe the Google Weather or Google Map as an example. I will show you in the example later. So you can connect any tools that is applicable to your project. And the latest one is the MCP tool. This is the latest technology. So for the agent framework, it's actually supporting different mainstream framework, I would say, like the length graph, length change, and so on. For today, code example, I will use the length chain as a start, but you can use other framework of your preference. So, of course, the model, you can also connect to any model from the model garden, but today we'll use the Gemini model. So, all good? A lot of theory, maybe you say, show me the code, right? As a technical person, enough talking, I want to look at the code. So it was very simple. So again, refresher, we have the AI agent with 4 components, 3 in the main. There's like a model, the tools, the reasoning, and the deployment. So it matched to what we will be using. For the model, we're using the Gemini, specifically 2.0 Flash. We're using the Gemini 2.0 Flash for today's session. Then the tools is something on the function calling. We will look into more details later. And then the reasoning, we are just connecting to the length chain. And deployment, we are using the agent engine. So all good? So let's see how we can do it very easily. First, we just import the libraries. So the libraries we need to do is the Vertex AI. And then from Vertex AI, we're just importing the agent engines and also the reasoning engines. I want to use the length chain agent. So you can use other agent that is available from the framework, Vertex AI framework also. So after that, first part, model. The simplest things. You just define what model you want to use. 2.0 Flash or 2.5, the latest one, 2.5 Flash that is in preview, that's also visible. Or you want to do other external models, maybe Mistra or Llama and all these that are available in the model garden also can support. So it's very easy. So for today's session, we will use the Gemini 2.0 Flash. And then on functions calling. So function calling is a method, I would say, define, just put it simple, where is you just define your own function that allow the LLM, send to LLM to pick up. So it can be your own function or function that connect to external API and all. We'll show you a few examples here. So the first function I define as a tool is the geocode address. So I want to convert I just give a string, let's say Sydney. It will return me the latitude and longitude of the location that is from the input data. So I want to get the coordinate of the location. So this is one simple function for geocode address. But of course, using this, I'm actually connecting to Google Maps API. So this is an external or built-in API that is supporting. So this is the first function I will define. The second function I define here as a tool is to search places. So with the query question, it will try to return me some places that is relevant to the question. Example is, if first time I'm coming to Google Sydney office, I don't know where to park, right? I can just ask how do I go to Google Sydney? then show me the locations, the parking locations. You'll be able to list out from the Google Map API. So it's very simple on that. Then the third function I define here is to create a satellite map. So just from the specific location defined, it's just creating a Google Map. So, and it will store to my cloud storage, and so that I can download and display it later. So for this example, I'm defining 3 different functions. I will show you how we can put it in place in the coding later. So we have 3 here. Now, let's come to the reasoning part. So you can just define as many functions or tools that you want to connect with the LLM model. So once it's done, we just define the agent. So to define the agent is very simple. We are just doing this agent equal to, we are using the LangChain agent here. So we just send in, setting the model as our Gemini 2.0 Flash. And then this is the main part. So I just define the tools, and then I just put in all the functions that I defined just now. So if you have any functions that you define, you just add it here. So you can have a list of different functions so that you can send into the agent. And surprisingly, with the prompt, the agent will know which tool is relevant. So you don't need to tell, if this is asking a map, you try to connect to this create satellite map function and return me the result. You don't have to explicitly mention it in the code and all. It will just automatically link it to the relevant tool set. So that's why it's very, very powerful and very, very simple to create an AI agent. So let's take a look on how we can test it out. To test it, to get the response right, I just call, once I define the agent, I just call the agent query and then your prompt. I'm visiting the Sydney, tell me what are the tourist attractions. So this is the response. So this is, you see that I'm not explicitly mention anything. So because this query, this prompt will send into the agent, and inside the agent, it will actually process and look into the tools, which one is actually relevant, and then we'll try to get the information from the tool, from the functions that you defined just now. Okay, right. Which one you recommend for a first-time visitor? Maybe it's the Opera House, is it? the iconic landmark in Sydney. So, yeah. So then, okay, I pick up, want to check on this Sydney Opera House. I also can just ask another question. Maybe I want to have dinner there, right? So restaurant nearby Sydney Opera House. You can see here, the prompt is just any simple, normal user questions, right? I don't ask it to direct it to which function that you should connect to and get me the answer. So just sending the prompt to the agent, you will just directly get the response out. Like the restaurant nearby, they have a few, I didn't check on it yet, but I think it should be correct. So yeah, so this is how you can directly, very flexible and also very powerful connecting to all these tools that you define. So this is on the testing the run agent. To test on the third one, right? So I have let's say I want to go look into the Sydney Opera House. And then I just get the like simple map of this location. So once, because in the, excuse me, the generating the satellite map there, I didn't ask it to generate the satellite map, right? I just asking it a simple question like this. We will actually generate the map and also store in my cloud storage. That's why I'm actually, this part is actually retrieving the image created and display it. So you can see it's a bird's eye view of the opera house that normally you don't see this angle, right? So yeah, so you can see it's very simple and direct. You don't have to specifically link your functions. Once you set it into the LM tools, it will automatically connect and also try to resonate which function is most relevant and get the information from there. So we have talked about the model, the tools, the reasoning with the LangChain. That's basically how we can easily develop an AI agent. The last part will be deployment. So how to do it is, I'll be just calling the agent engines and create the with the agent, and then just this one is just the requirements on the agent engine parts. So you can see that it can just, we will directly deploy to the Google Cloud AI engine in. Then you can just call the remote engine to send in the different questions or prompts and get the same response from the model being deployed. So it's all very simple as that. So 1, 2, 3, 4 steps, you are done. Chill, right? Simple, right? So I will show you, let me see, I have some time. So, yeah. So I will connect this notebook with the slide, and I will share to the organizer. You can get it later and try the hands-on. Because of the time, we will not be able to run it together, but all in all, it's already. You can take a look on, you can change different things. Like I can also want to create the satellite tower eye, and you can show you different question that I try on. This is the restaurant, and yeah, I can also like reverse. I want to promote tourism of Malaysia. Welcome to Malaysia next time. So like all the top tourist places from the Malaysia, then yeah, you can get the similar answer of the tourist spot, maybe the KLCC Twin Tower and what's not. So that's very easy to develop an AI agent, of course. So to say, this is just an example, the very basic of it. You can mix, the technology is getting evolved. We want to solve more complicated use cases, right? Then you have all this multi-agent framework, but it's based on this. Once you get this information in place, it's very easily you can expand it to multi-agent. You can have an agent to, let's say I want to develop a travel app. So maybe I have one agent to look for my flight agent, right? Then maybe I have another agent for the accommodation booking. So you can have different agents to look into different tasks and role responsibility. So you can map that, or even you can directly link it another agent to connect to this currency, also the weather and what's not. So you can, very simple to do that. Then here's the quick takeaways. The agentic AI is autonomous AI, capable to perceive the environment, making decision and acting to achieve the set of goal. We don't want to, it's not to say not good. We are not satisfied with just simple AI chatbot. After you have get the answer, and then you have to copy and paste, and then maybe you have to do the tasks differently or manually, right? How can we kind of automate the process? right? You can connect from here. So we also show you the Vertex AI agent engine. It's a fully managed Google Cloud services and able the developers to deploy and manage AI agent in production level. But to build the AI agent, develop the AI agent, first you just define the functions. For this example, is using the currency exchange. And then you define the agent, the model, and the tools. Say it to the agent. For this case, we are using the LangChain agent. And then once you are done, you just deploy to Vertex AI using the agent engine. So 1, 2, 3 step, you are done. Trust me, it's simple. But of course, this is just a simple project. But in the real life project wise, things can be much more complicated because you want to do more things with more agents, right? So, but it's good to get started. That's all. Any question? Happy to answer. Yes.
Hi, my name is Abdullah. I just wanted to ask about a line in the code that temperature is equals to 0. Is it the like you are avoiding foul words in the prompt? This temperature is equal because KVogs. I think this is something I can relate back to Microsoft AI in AI Foundry. That's the same field.
Yeah.
Is it the same?
Same parameter to control how creative or how rigid the answer response from the model.
Thank
If
you.
you want to be very creative, if you are doing a use case for writing a poem or song lyrics and all, maybe you want to say it higher, but all these factual things set to a low level, low value.
My name is Sanjay. You mentioned somewhere that AI is capable of making decisions, right? How do you ensure that it's making the correct decision? What do you do within that space?
Good question. It's always getting this kind of question and right. It's it depends on how you design your architecture framework. If you see that, if I think in general use cases like this, it's very simple and different tasks is very easily to be identified or separate out. So generally the model will not get confused. But in case the model get confused into very similar functions, then what you can do is design architecture-wise, you can have another agent try to reflect the coding.
Okay.
You have one agent to do the coding, then another agent to test it, is the code correctly or not.
Okay. Yeah.
But it's still, I would say, it's getting there, but it's not like 100% mature.
Yeah.
I think things will get better and all, but you can always have all this reflective agent to cross-check.
Valid. Okay. Thank you.
Can be. So that's why I said, this is very simple architecture design. When the real life application and all, you will have all this complex scenario that you want to ensure the response is always correct and all those things. Then you will have a lot more to think of. Yeah.
I just want to add something. I guess something you can do is request a structured JSON back. And if you have some business rules or requirements, you could kind of check and pass it and say like, oh, is this long or whatever?
Yeah, this is one way of the rectify the answer is correct or not. You can define the schema. If let's say you're connecting to your company database and what's not, you have your database schema and all right. You kind of have defined it, the schema on the LM response, but also you have another agent to cross-check if the answer is similar to the exactly the same schema or not. If not, then you will not be able to fetch any query from your database. You directly easily spot the errors. Not say 100% will always correct, but it's slowly improving, yeah? Yeah.
Hi there. I've been seeing no-code platforms like N8 and Relevance where, you know, even the most non-technical users can kind of develop their own AI agents. I was just wondering what a use case would be for someone to code their own AI agent as opposed to using something like N8 or Relevance?
Right. As you can see, things are getting, or AI is getting smarter and smarter and can be automated more and more. All this technology evolving and all, we have all this new term called web coding and all. Fix this for me. You don't even know what it's doing and how to do it. Then, but magically, it's done for you. It's unfortunately, good or bad, it's really moving into that direction. So I would say is how we are not able to avoid this, or we try to push it. It's happening right now. The point is that how can we upskill ourselves to also be able to work with all these technology changes. Yeah, it will getting more and more no code, even like this compared to last time doing the AI model training and all. Now it's just snap of finger, it's done for you, right?
Cool. Any other questions?
We have swag.
Wait,
if you
there
have
is swag, but
Yeah.
is it a sticker?
It's a sticker.
Oh,
Yeah.
it's
It's
stickers.
a really nice sticker.
Yeah.
Maybe I
Some-
should also get one.
Super glossy, you know. They're cool. There you go.
Yeah, if not,
No?
then that's it.
Awesome. Thank you very much.
Thank you. Happy to connect with from my LinkedIn.
Thank you, Leong.